Picture this: a swirling cosmic masterpiece, glowing with colors no artist could ever replicate, hiding secrets that defy everything we know about the universe. This isn't science fiction. This is the Orion Nebula, a place where stars are born, where gas dances in shapes that seem almost alive, and where the rules of physics twist into something strange. Right now, buried in that sea of light and shadow, there are mysteries waiting to be uncovered, phenomena so bizarre they'll make you question what's really out there. Some of them glow with energies we can't explain, others move in ways that shouldn't be possible, and a few might just rewrite the textbooks. Over the next few minutes, we're diving deep into 50 of the most jaw-dropping, spine-tingling wonders hidden within the Orion Nebula. From ghostly silhouettes to cosmic explosions frozen in time, each one is a puzzle begging to be solved. So buckle up, because by the time we're done, you'll never look at the night sky the same way again. And trust me, what's coming will surprise even the most seasoned stargazers. Let's begin. Now, let's zoom straight into the heart of the Orion Nebula, a place where the cosmos puts on its most dazzling light show. At the center of this celestial spectacle lies what astronomers call the Great Orion Nebula's glowing heart, a region so bright it outshines nearly every other nebula in our galaxy. But what makes it burn so fiercely? The answer lies in a cosmic nursery teeming with newborn stars. These young stars, some barely 1,000,000 years old, are like cosmic powerhouses, blasting out torrents of ultraviolet radiation. That energy slams into the surrounding clouds of hydrogen gas, stripping electrons from their atoms in a process called ionization. The result, a radiant glow that paints the nebula in hues of pink, purple, and blue. Colors that aren't just beautiful but tell the story of star birth itself. And here's the wild part: this glowing heart isn't just a static beacon. It's alive with motion. The same stellar winds that light up the gas also sculpt it, carving cavities and pillars that shift over centuries. It's like watching a celestial artist at work, where the canvas is made of gas and the brushstrokes are pure energy. So when you gaze at that glowing core, remember, you're not just seeing light. You're witnessing the raw power of creation, where stars are forged and the universe reveals its brilliance in ways we're only beginning to understand. But the Orion Nebula's brilliance isn't just a solo act, it's a cosmic ensemble performance, and the stars at center stage are the Trapezium cluster. Picture 4 dazzling stars, each several times hotter and more massive than our Sun, locked in a gravitational dance at the heart of the nebula. These aren't just any stars, they're the power players behind the nebula's glow. Their fierce ultraviolet radiation acting like a cosmic spotlight that sets the surrounding gas ablaze with light. What makes this cluster so fascinating isn't just their brightness, but their intricate choreography. These stars whirl around one another, their gravitational pull shaping the very fabric of the nebula. Their interactions fling gas and dust into swirling patterns, carving out cavities and sculpting the pillars we see in iconic images. It's like watching a celestial ballet, where every movement leaves a lasting mark on the stage of space. And here's the kicker: without the Trapezium cluster, the Orion Nebula as we know it wouldn't exist. Their radiation doesn't just light up the gas, it also prevents the nebula from collapsing under its own weight, maintaining the delicate balance between chaos and creation. So next time you admire the nebula's glow, remember, it's these 4 stellar dancers locked in their eternal performance that make the entire show possible. Now, let's turn our attention to one of the Orion Nebula's most puzzling features, the enigmatic Orion Bar. This dark, jagged ridge of gas and dust slices through the nebula like a cosmic scar, standing out starkly against the glowing backdrop. Unlike the wispy, flowing shapes we often associate with nebulae, the Orion Bar is dense, structured, and almost defiant in its rigidity. What makes this bar so unusual is how it challenges our expectations of how nebulae should behave. Typically, these cosmic clouds are chaotic and ever-changing, but the Orion Bar holds its shape with surprising resilience. Scientists believe its structure is shaped by an intense tug-of-war between the Trapezium cluster's blistering radiation and the bar's own stubborn density. The radiation pushes against the bar, eroding it slowly, while the dense material resists, creating a sharp boundary where light and shadow collide. But the Orion Bar isn't just a cosmic oddity. It's also a bustling laboratory for some of the universe's most fascinating chemistry. Known as a photodissociation region, it's a place where ultraviolet light from nearby stars tears molecules apart, only for them to recombine into new, complex forms. This process creates a rich soup of compounds, from simple hydrogen to more exotic molecules, offering a glimpse into how the building blocks of life might form in space. So while the Orion Bar might look like a dark, silent divider, it's actually a dynamic frontier, a place where destruction and creation dance in perfect balance. And for astronomers, it's a golden opportunity to study the forces that shape not just nebulae, but the very ingredients of the cosmos. Shifting our gaze to another captivating feature of the Orion Nebula, we encounter the mysterious silhouette known as the Running Man. This striking formation, sculpted by dense clouds of dust and gas, appears to stretch across the cosmos like a shadowy figure mid-sprint. Its uncanny resemblance to a human runner has sparked both scientific curiosity and imaginative folklore among astronomers and stargazers alike. What makes the Running Man so intriguing is how its shape emerges from the interplay of light and shadow. The dark dust clouds block the intense glow of the nebula behind them, carving out a figure that seems almost purposeful in its design. Some astronomers joke that it looks like a cosmic athlete racing through the stars, while others see it as a reminder of how our minds instinctively seek familiar patterns in the chaos of space, a phenomenon known as pareidolia. But beyond its eerie appearance, the Running Man holds scientific significance. The dust that forms this silhouette is part of a larger network of cold, dense material that serves as a nursery for future stars. These regions, shielded from the harsh radiation of nearby stars, may one day collapse under their own gravity, igniting new stellar births. So while the Running Man might seem like a fleeting shadow, it's actually a snapshot of a much grander cosmic process. Whether you see it as a celestial sprinter or a cosmic coincidence, the Running Man adds another layer of wonder to the Orion Nebula's already mesmerizing tapestry. And for those who love a good story, it's a reminder that the universe has a way of sparking our imagination as much as it fuels our scientific discoveries. Now, let's turn our attention to one of the most visually striking features of the Orion constellation, the so-called Sword of Orion. This celestial arrangement isn't just a random cluster of stars and gas. It's a carefully positioned cosmic illusion that blends science with ancient mythology. At first glance, the Sword of Orion appears as a faint, dangling line of stars beneath the hunter's belt. But nestled within this seemingly simple asterism lies the Orion Nebula, transforming the sword from a basic star pattern into a gateway to deeper cosmic wonders. The nebula's glow gives the sword an almost ethereal quality, as if it's not just a weapon in Orion's hand but a luminous key to the universe's secrets. What makes this alignment so fascinating is how it plays tricks on our perception. From Earth, the nebula appears as part of the sword, but in reality, it's much farther away, about 1,300 light-years distant, while the stars forming the sword's outline are relatively closer. This creates a celestial mirage where depth and distance blur into a single, mesmerizing spectacle. Ancient civilizations saw this as a divine sign or a literal sword wielded by the hunter Orion, while modern astronomers recognize it as a chance alignment that reveals the universe's layered complexity. Mythology adds another layer to the illusion. In many cultures, Orion's sword symbolized power, protection, or even a bridge between worlds. Today, it serves as a bridge of a different kind, connecting human imagination with scientific discovery. Whether you view it through the lens of legend or astrophysics, the Sword of Orion reminds us that sometimes the most captivating cosmic wonders are those that blur the line between what we see and what lies beyond. And as we continue unraveling the Orion Nebula's mysteries, this celestial sword stands as a testament to how the universe weaves together light, distance, and storytelling into a single, unforgettable vision. Now, shifting our gaze slightly from the Sword of Orion, we encounter one of the most hauntingly beautiful sights in the cosmos, the Horsehead Nebula. This dark nebula isn't just a cosmic silhouette, it's a masterpiece of shadow and light sculpted by the forces of star formation and interstellar winds. The Horsehead Nebula gets its name from its unmistakable shape, a towering column of dust and gas that resembles the profile of a horse's head, complete with a flowing mane. But this isn't just a random cloud. It's a dense, cold region where gas and dust have clumped together, blocking the light from the glowing emission nebula behind it, known as IC 434. The contrast between the dark nebula and the bright red hydrogen gas creates the illusion that the Horsehead is floating in space, like a ghostly figure emerging from a cosmic fire. What makes this nebula so fascinating is how it formed. The intense radiation from nearby young stars, particularly Sigma Orionis, is slowly eroding the Horsehead structure, sculpting it into its iconic shape. Over thousands of years, this stellar wind will eventually disperse the nebula entirely, meaning we're witnessing a fleeting moment in its cosmic lifespan. But the real magic lies in its three-dimensional illusion. From Earth, the Horsehead appears to hover in front of the glowing gas, but in reality, it's part of a much larger complex of dust and gas within the Orion molecular cloud. The alignment is just right for us to see this striking silhouette, a reminder of how perspective can turn ordinary cosmic material into something extraordinary. Whether you're an astronomer or a casual stargazer, the Horsehead Nebula captures the imagination. It's a celestial work of art, blending science and wonder, and a testament to the universe's ability to create beauty even in the darkest corners of space. Just beyond the haunting silhouette of the Horsehead Nebula lies another cosmic spectacle that seems to defy the cold emptiness of space, the Flame Nebula. This fiery-looking region doesn't burn with actual flames, but its vivid glow gives the illusion of a celestial wildfire crackling with energy. The secret behind this dazzling display lies in the intense ultraviolet radiation pouring from Alnitak, the easternmost star in Orion's belt. This massive hot star acts like a cosmic blowtorch, energizing the surrounding hydrogen gas until it emits a radiant red glow. But the Flame Nebula isn't just a backdrop, it's a bustling stellar nursery. Hidden within its swirling clouds are newborn stars, their fierce winds and radiation sculpting the gas into dramatic pillars and cavities. What makes this nebula truly fascinating is its layered structure. Dark lanes of dust weave through the glowing gas, creating intricate patterns that resemble smoke rising from a fire. These dust filaments aren't just for show, they're the raw material for future stars slowly collapsing under gravity's pull. Meanwhile, the nebula's brightest region, known as NGC 2024, hosts a cluster of young stars so energetic they've blown a bubble in the surrounding gas, revealing the turbulent heart of this cosmic forge. Unlike earthly fires, the Flame Nebula's glow isn't fleeting. It's a slow, persistent simmer fueled by stellar radiation over millions of years. Yet even this fiery giant has an expiration date. Eventually, the very stars it birthed will disperse its gas, leaving behind only scattered starlight. For now, though, it stands as one of Orion's most striking illusions. A fire that doesn't burn but shines with the brilliance of creation itself. Now, let's turn our gaze to something far grander yet surprisingly elusive: Barnard's Loop. This colossal arc of faint, glowing gas stretches across Orion like a cosmic embrace, so vast it could wrap around the entire constellation. But here's the twist: despite its size, you won't spot it with a casual glance. Its delicate glow requires dark skies and patience, making it a hidden masterpiece of the night. The story of Barnard's Loop begins with violence. Astronomers believe it's the remnant of a supernova explosion that rocked this region of space millions of years ago. The shockwave from that cataclysm blasted gas outward, sculpting it into this faint, bubble-like structure. Today, the loop still glows, energized by the ultraviolet light of Orion's brightest stars like Rigel and Betelgeuse. It's a ghostly echo of stellar destruction, now repurposed as a canvas for new star formation. What's mesmerizing about Barnard's Loop is its scale. Spanning hundreds of light years, it dwarfs even the Orion Nebula, yet it's often overshadowed by its brighter neighbors. Its faintness comes from its thin, diffuse gas. Imagine a wisp of smoke compared to the dense clouds of the Flame Nebula. But that subtlety hides its importance. The loop acts like a cosmic feedback loop, its gas recycling into new stars, while its structure reveals the turbulent history of Orion's stellar generations. For amateur astronomers, spotting Barnard's Loop is a badge of honor. It's a test of both equipment and sky conditions, a reminder that the universe's grandest spectacles often whisper rather than shout. And for scientists, it's a puzzle how much of its shape comes from that ancient supernova and how much from the stellar winds of Orion's giants. One thing's certain: this faint arc is a silent witness to the cycles of birth, death, and rebirth that define our galaxy. Now, let's step back and take in the bigger picture: the Orion Molecular Cloud Complex. This isn't just a single nebula or cluster. It's an entire cosmic metropolis, a sprawling network of gas and dust where stars are born by the thousands. Think of it as the universe's most productive factory, humming with activity across hundreds of light years. At the heart of this complex lies the Orion Nebula, but it's just one neighborhood in a much larger city. The complex is made up of multiple molecular clouds, dense, cold regions where gas clumps together under gravity's pull, eventually collapsing to ignite new stars. These clouds are so massive that they contain enough material to form tens of thousands of stars like our Sun. And the Orion Nebula, it's simply the brightest, most visible part of this star-forming frenzy, like a spotlight on a crowded stage. What makes this complex so fascinating is its role in stellar evolution. Here, stars don't just form in isolation. They're born in clusters, often triggering waves of new star birth as their radiation and winds compress nearby gas. It's a chain reaction, with one generation of stars setting the stage for the next. The Orion Nebula, for example, is sculpted by the Trapezium stars, whose fierce energy carves out cavities and pillars in the surrounding cloud structures that will someday collapse into even more stars. But the complex isn't just a nursery, it's also a time capsule. By studying its different regions, from the dense cores hiding protostars to the diffuse outskirts where gas is just beginning to gather, astronomers can piece together the life cycle of stars from their earliest whispers to their fiery maturity. And because it's relatively close to Earth, just about 1,300 light years away, it's one of the best places to witness this cosmic drama unfold in real time. So the next time you gaze at Orion's sword, remember, you're not just looking at a single nebula. You're seeing a tiny fragment of a vast, dynamic ecosystem where stars are born, live, and die in a cycle as old as the galaxy itself. Now, let's zoom in on one of the most dynamic and visually stunning phenomena in the Orion Nebula: Herbig-Haro objects, or HH objects for short. These are the cosmic jets fired off by newborn stars, streaking through space at speeds that defy imagination. Picture a star in its infancy, still gathering material from its surroundings. As it feeds, it doesn't just pull gas in, it also blasts some of it back out in narrow, high-speed jets. These jets slam into the surrounding nebula at hundreds of thousands of miles per hour, creating shock waves that glow like celestial fireworks. What makes HH objects so mesmerizing is their chaotic beauty. They twist, knot, and fan out in intricate patterns, painting the nebula with streaks of light. Some look like delicate tendrils, while others resemble violent splashes, as if the universe itself were flicking paint across the cosmos. And because these jets are constantly shifting, HH objects change shape over time, offering astronomers a front-row seat to the turbulent youth of stars. But there's more to these jets than just their artistry. They're a crucial part of star formation. As a young star ejects material, it helps regulate its own growth, preventing it from spinning out of control or becoming too massive. The jets also carve out cavities in the surrounding gas, clearing space for future generations of stars to form. In a way, HH objects are both the birth cries and the sculpting tools of stellar nurseries. The Orion Nebula is home to some of the most famous HH objects like HH1 and HH2, which were among the first to be discovered. Their vivid, tangled structures reveal the raw energy of star birth, a reminder that even in the vast quiet of space, creation is anything but gentle. So next time you see an image of the Orion Nebula, look closely. Those faint, wispy trails aren't just cosmic decoration. They're the signatures of stars fighting to be born. Now let's turn our attention to something equally fascinating but far more delicate: the proplyds, or protoplanetary disks, scattered throughout the Orion Nebula. These are the cosmic cradles where planets are born, and the Orion Nebula is one of the best places in the universe to study them. Imagine a young star still swaddled in a thick, rotating disk of gas and dust. Over millions of years, this disk clumps together, forming everything from tiny asteroids to giant planets. What makes proplyds in Orion so special is their sheer visibility. Thanks to the nebula's intense radiation, many of these disks are literally being lit up from the outside like celestial lanterns. Some appear as tiny, glowing teardrops, their shapes stretched by the stellar winds from nearby massive stars. Others look like dark silhouettes against the nebula's bright backdrop, their dense dust blocking the light behind them. It's a cosmic tug of war. Radiation tries to erode these disks, while gravity works to hold them together, shaping the future of entire planetary systems. The discovery of proplyds in Orion was a game-changer for astronomy. Before the Hubble Space Telescope captured their images in the 1990s, scientists had only theorized about how planets formed. Now we could see it happening in real time. These disks aren't just passive rings of debris, they're dynamic, chaotic environments where dust grains collide, stick together, and eventually grow into planets. Some even show gaps and spirals, hints of newborn worlds carving their paths through the material. But the Orion Nebula doesn't just show us how planets form, it also reveals how harsh the process can be. The most massive stars in the nebula bombard nearby proplyds with ultraviolet radiation, stripping away their outer layers and potentially limiting their ability to form gas giants like Jupiter. It's a reminder that not all stellar nurseries are gentle, and not all disks get the chance to finish their planetary creations. Yet, despite these challenges, proplyds endure. They're a testament to the resilience of cosmic evolution, proving that even in the most turbulent environments, the building blocks of worlds find a way. So the next time you gaze at the Orion Nebula, remember, those faint, glowing disks aren't just pretty features. They're the blueprints of solar systems, the silent architects of planets yet to come. Now, let's unravel one of the Orion Nebula's most puzzling secrets: its magnetic fields. While we often picture nebulae as chaotic swirls of gas and dust, there's an invisible force at work shaping their structure: magnetism. The Orion Nebula's magnetic fields are like cosmic puppet strings, subtly guiding the movement of gas and even influencing how stars are born. Scientists have discovered that these magnetic fields aren't uniform. Instead, they twist and tangle, creating a complex web that channels ionized gas into specific pathways. Imagine a river diverted by hidden currents. the nebula's magnetic fields do something similar, steering material into dense filaments where gravity can take over and collapse it into new stars. Without these magnetic forces, the nebula might look entirely different, with stars forming in entirely different patterns. But here's the mystery. While we know magnetic fields play a role, their exact strength and structure in Orion remain hotly debated. Some regions show tightly wound magnetic lines like coiled springs, while others appear more relaxed. These variations could explain why some parts of the nebula are bustling stellar nurseries, while others seem eerily quiet. Even more intriguing is how these magnetic fields interact with the nebula's intense radiation. Ultraviolet light from massive stars doesn't just ionize gas, it also disrupts magnetic alignments, creating a tug of war between order and chaos. In some cases, this might even trigger star formation by compressing gas along magnetic highways. What's clear is that magnetism is a silent architect in the Orion Nebula, shaping its beauty and complexity in ways we're only beginning to understand. So the next time you admire those glowing clouds, remember, there's more at work here than meets the eye. Now, let's shift our gaze to the shadowy rivers cutting through the Orion Nebula, the so-called dark lanes. These twisting filaments of dust aren't just empty voids, they're dense cosmic highways made of tiny particles, each no larger than a grain of sand. But don't let their size fool you. When these particles clump together, they form vast, intricate structures that block starlight, carving out eerie silhouettes against the nebula's glowing backdrop. What's fascinating is what these dust lanes are made of. They're not just simple space dirt, they contain complex molecules, including silicates and carbon-based compounds, some of which are the very building blocks of planets. Picture them as cosmic construction sites where future worlds might one day take shape, but for now they act like a celestial veil, absorbing and scattering light so effectively that entire regions of the nebula appear to vanish behind them. These dark lanes also play a crucial role in star formation. By shielding pockets of gas from the intense radiation of nearby stars, they create quiet nurseries where gravity can slowly work its magic. Without these dust rivers, the nebula's gas might be blown apart before it could ever collapse into new stars. It's a delicate balance: too much dust and light can't escape, too little and stellar birth becomes chaotic. And here's something mind-bending: some of these lanes aren't static. They shift and ripple over time, responding to the push and pull of magnetic fields and stellar winds. In a way, they're like slow-motion rivers of shadow, constantly reshaping the nebula's landscape. So while they might seem like mere absences of light, these dark lanes are anything but empty. They're dynamic, vital threads in the Orion Nebula's ever-changing tapestry. Now, let's peer beyond the visible and into the hidden heart of the Orion Nebula, where ordinary light can't reach. Nestled within those dense dust lanes we just explored are countless stars shrouded in cosmic secrecy, visible only through the eye of infrared astronomy. These aren't just any stars, they're infant suns swaddled in thick blankets of dust, their light smothered before it can escape to our telescopes. But infrared cameras cut through the veil, revealing a bustling stellar nursery we'd otherwise miss entirely. What makes these hidden stars so special? For starters, they're some of the youngest stars in the nebula, some still gathering mass from their dusty surroundings. Without infrared technology, we'd have no clue they were there, which means our understanding of star birth would be full of gaps. Imagine trying to piece together a puzzle with half the pieces missing. That's what studying stellar nurseries would be like without these invisible stars. But here's where it gets even more intriguing. Some of these buried stars are throwing tantrums, launching powerful jets of gas as they grow, like cosmic toddlers kicking up dust. These jets, visible in infrared, carve intricate paths through the nebula's gas, shaping their surroundings in ways that visible light alone could never show us. It's a reminder that the Orion Nebula isn't just a static painting. It's a dynamic construction zone with hidden workers toiling away behind the scenes. And the implications go beyond Orion. By studying these dust-cloaked stars, astronomers can test theories about how all stars form, even those in distant galaxies. It's like finding a secret backdoor into the universe's star-making factories. So while these infrared hidden stars might not dazzle us with visible light, they're quietly rewriting the textbooks on cosmic birth. Next time you gaze at Orion's sword, remember there's an entire invisible drama unfolding there, waiting to be uncovered. Now, let's turn our attention to a cosmic light show that defies expectations, the Orion Nebula's ever-changing glow. Unlike the steady twinkle of distant stars, this nebula pulses and dims unpredictably, as if breathing with a rhythm of its own. What's behind this celestial flickering? The answer lies in the turbulent dance between newborn stars and the swirling sea of gas that surrounds them. At the heart of the mystery are the nebula's massive young stars, particularly those in the Trapezium cluster. These stellar powerhouses blast out intense ultraviolet radiation, which lights up the surrounding gas like a neon sign. But here's the twist: their energy output isn't constant. Some stars experience violent outbursts while others temporarily dim, causing the nebula's glow to wax and wane. Imagine a spotlight operator constantly adjusting the brightness. That's essentially what's happening here, but on a cosmic scale. Then there's the gas itself. The nebula isn't a uniform cloud, it's a maze of dense knots and wispy filaments. As these structures shift and collide, they can block or amplify light in unexpected ways. A thick dust lane might drift in front of a bright star, dimming its glow for decades, while a sudden clearing in the gas could make another region flare up. It's like watching sunlight filter through moving clouds, except the clouds are light years wide and made of ionized hydrogen. But the surprises don't stop there. Astronomers have even spotted light echoes, delayed reflections where bright stellar flashes bounce off distant dust walls, creating ghostly afterglows that fade over years. These echoes act like cosmic time capsules, revealing past eruptions we otherwise would have missed. So why does this matter? Because these brightness changes aren't just a pretty light show, they're clues. By tracking them, scientists can map hidden structures in the nebula, measure distances more accurately, and even predict how the region might evolve. Next time you see Orion in the night sky, remember, its famous nebula isn't just shining, it's telling a story one flicker at a time. Now, let's venture into one of the most heated debates surrounding the Orion Nebula. Could part of this cosmic wonder actually be the ghostly remains of a long-dead star? The supernova remnant theory suggests that hidden within the nebula's glowing gas lies evidence of a cataclysmic explosion from the distant past. Astronomers first suspected this when they noticed unusual features in the nebula's structure. Certain regions show shockwaves ripples in the gas that resemble the aftermath of a violent blast. These aren't the gentle swirls of star formation, but jagged, energetic patterns, like scars etched into the cosmos. Then there's the presence of rare elements like aluminum-26, which are often forged in supernova. Finding them here is like stumbling upon cosmic shrapnel, hinting at an ancient explosion. But not everyone's convinced. Critics argue that the nebula's young stars and active star-forming regions don't align with the timeline of a supernova. If a massive star had exploded here, wouldn't it have disrupted the delicate process of stellar birth? Supporters counter that the explosion could have happened just beyond the nebula, its shock waves merely brushing the gas we see today. It's like finding seashells on a mountain, proof of an ancient ocean, even if the water is long gone. The debate gets even trickier when we consider the nebula's missing mass. Some calculations suggest there's more gas here than we can observe. Could the lost material have been blasted away by a supernova, leaving behind only echoes? Or is there another explanation, like hidden dust or magnetic fields? What makes this mystery so compelling is that it challenges our understanding of Orion's history. If a supernova did occur here, it would rewrite the nebula's story, adding a dramatic chapter of destruction before the beauty we see today. Until we uncover more evidence, this cosmic whodunit remains unsolved, a tantalizing puzzle at the heart of one of the sky's most famous landmarks. Shifting our gaze to another enigmatic feature of the Orion Nebula, let's unravel the secrets of Orion's veil, a delicate, almost ghostly curtain of gas that drapes across this cosmic landscape. Unlike the nebula's vibrant glow or chaotic dust lanes, this wispy layer is subtle, acting like a celestial filter that softens and scatters the intense light from nearby stars. Picture it as a sheer cosmic veil woven from hydrogen and other ionized gases, stretching across vast distances. What makes it fascinating is how it interacts with starlight. As light from young, blazing stars passes through this gauzy barrier, certain wavelengths get absorbed or redirected, creating a natural dimming effect. Astronomers call this process extinction, but it's less about destruction and more about transformation. The veil subtly alters the light's journey, much like frosted glass diffuses sunlight. But Orion's veil isn't just a passive screen. Its structure holds clues about the nebula's environment. The gas here is incredibly thin, almost ethereal, yet it's shaped by powerful forces: stellar winds, radiation pressure, and even magnetic fields. Some sections appear frayed or torn, suggesting turbulent encounters with energetic particles. It's as if the veil is a cosmic weather vane, revealing the invisible storms raging through the nebula. What's even more intriguing is how this feature challenges our perception of depth in space. Because the veil lies between us and the nebula's brighter regions, it creates an illusion of layers, adding a sense of three-dimensional grandeur to Orion's portrait. Without it, the nebula might look flat, like a painted backdrop. Instead, the veil gives it texture and mystery, a reminder that even in the vastness of space, delicate structures can have a profound impact. So next time you gaze at Orion, remember, that faint, shimmering haze isn't just empty space. It's a dynamic, ever-shifting curtain, quietly shaping the light of stars and the stories we tell about them. Now, let's dive into something truly mind-bending: the Orion Nebula's chemical soup. This cosmic cauldron isn't just a swirl of gas and dust. It's a bustling factory of exotic molecules, some of which are the very building blocks of life. Imagine a vast interstellar kitchen where water, carbon monoxide, and even complex organic compounds like methanol and formaldehyde are simmering among the stars. What's astonishing is the sheer variety. Scientists have detected everything from simple molecules like hydrogen and helium to more complex ones, including polycyclic aromatic hydrocarbons, fancy term for carbon-rich compounds often found in soot or barbecue grills, but here they're floating in space. Then there's water, not just as vapor but locked in icy grains clinging to dust particles. And let's not forget glycine, the simplest amino acid, which hints at the possibility of life's ingredients being forged in these stellar nurseries. But why does this matter? These molecules aren't just cosmic curiosities, they're clues. The presence of organic compounds suggests that the raw materials for life might be scattered throughout the universe, waiting for the right conditions to assemble into something more. Astrobiologists get especially excited about this because if such molecules can form in the harsh environment of a nebula, they could seed planets, giving life a head start wherever it takes root. Even more intriguing is how these chemicals interact. Radiation from young stars breaks apart molecules, only for them to recombine into new forms, creating a dynamic, ever-changing chemistry lab. Some regions are rich in oxygen-bearing compounds, while others are carbon-heavy, painting a patchwork of chemical diversity. It's like the nebula is experimenting with recipes, testing which combinations might one day spark life elsewhere. So when you look at Orion's glowing clouds, remember, you're not just seeing light and color. You're witnessing a cosmic alchemy lab where the elements of life are being stirred, shaken, and scattered across the universe. And who knows, some of those molecules might eventually find their way into a planet's oceans or even its living cells. The Orion Nebula isn't just a sight to behold. It's a reminder that the universe is far more chemically creative than we ever imagined. Now, let's shift our gaze to another breathtaking spectacle, the stellar wind sculptures of the Orion Nebula. Picture this: colossal stars, some dozens of times more massive than our Sun, unleashing torrents of charged particles at speeds nearing millions of miles per hour. These aren't gentle breezes, they're cosmic hurricanes, and they're the artists behind some of the nebula's most striking formations. These stellar winds act like celestial chisels, carving out vast cavities in the surrounding gas clouds. Imagine a sculptor blasting away at a block of marble, only here, the marble is a sea of hydrogen and dust, and the sculptor is a star with unimaginable energy. The result, bubbles and hollows that stretch for light years, their edges glowing where the wind collides with denser gas. But the winds don't just erase, they also create. In regions where the gas is thicker, the winds can't sweep it all away. Instead, they compress what's left, forging towering pillars like the famous Pillars of Creation in other nebulae. These structures are cosmic nurseries, their dense cores sheltering fledgling stars from the very winds that shape them. It's a beautiful paradox. The same force that tears apart the nebula also nurtures new stars within it. What's truly mesmerizing is the delicate balance at play. Too much stellar wind and a pillar disintegrates, too little, and it never forms at all. The Orion Nebula's most iconic shapes exist in this precarious dance, their survival a testament to the interplay of chaos and creation. And because these winds are relentless, the sculptures are always changing. What we see today might be reshaped or even erased in a cosmic blink. So when you marvel at the nebula's swirling clouds, remember the invisible hands shaping them. Those ethereal arches and shadowy columns aren't just static art, they're snapshots of an ongoing masterpiece crafted by the breath of stars. It's a reminder that even in the vastness of space, nothing stays still, and beauty is often born from the most violent forces. Now, let's turn our attention to a puzzle that has left astronomers scratching their heads: the true age of the Orion Nebula. You'd think something so grand and luminous would have a straightforward birth date, but the cosmos loves a good mystery. Estimates of this stellar nursery's age vary wildly, from just 1 million years to several million, and pinning down the exact number is anything but simple. Why the confusion? For starters, the Orion Nebula isn't a single, uniform structure. It's a bustling cosmic neighborhood where stars are born at different times, creating layers of history. Some of its youngest stars are still swaddled in gas, while others nearby have already begun their stellar lives. This mix of ages makes it hard to define a single birthday for the entire nebula. Then there's the challenge of measuring stellar ages itself. Astronomers often rely on clues like a star's brightness, temperature, and stage of evolution. But these methods aren't perfect. Some stars mature faster than others, and environmental factors can skew the data. Imagine trying to guess the age of a group of children when some grew up in a bustling city and others in a quiet village. The differences in their development would make your job a lot harder. Adding to the complexity, the nebula's gas and dust clouds are constantly shifting, erasing some of the cosmic paper trail. It's like trying to reconstruct a family tree when half the records have been blown away by the wind. Some researchers argue that parts of Orion might even be remnants of older star-forming regions, further muddying the timeline. So what's the takeaway? The Orion Nebula is a living, evolving entity, not a frozen snapshot in time. Its age isn't just a number, it's a story still being written, one that reminds us how dynamic and unpredictable the universe can be. And for astronomers, that's part of the thrill. The hunt for answers continues, and every new discovery adds another piece to the puzzle. Now, let's step back in time and see how ancient eyes gazed upon the Orion Nebula. Long before telescopes peeled back its cosmic layers, This glowing patch in Orion's sword was more than just a smudge in the night sky. It was a canvas for human imagination. To the naked eye, the nebula appeared as a faint, fuzzy star, but cultures around the world wove it into their myths and legends. The Maya saw it as the fiery hearth of creation, a cosmic fire where the gods kindled new life. Meanwhile, ancient Egyptians linked it to Osiris, their god of the afterlife, believing its glow was a celestial torch guiding souls to rebirth. Not every civilization romanticized it, though. Some Greek astronomers dismissed it as a mere atmospheric flaw, a cloud marring the perfection of the heavens, but others, like the Babylonians, recorded its position meticulously, treating it as an omen, its brightness shifting like a divine signal. What's fascinating is how these interpretations reflect more than just astronomy. They reveal humanity's timeless urge to find meaning in the unknown. Whether as a sacred symbol or a scientific curiosity, the Orion Nebula has always sparked wonder. And while we now understand its true nature, those ancient stories remind us that the sky has always been a mirror, reflecting our dreams, fears, and endless curiosity. Next, we'll tune into the nebula's faint radio whispers, a hidden language of the cosmos that modern technology has only just begun to decode. But hidden beneath the glow of starlight and swirling gas, the Orion Nebula has another story to tell, one that hums quietly in the static of the cosmos. These are its radio whispers, faint signals rippling through space that only our most sensitive instruments can detect. Unlike the dazzling light we see, these radio waves pierce through dust and gas, revealing secrets the nebula keeps hidden from optical telescopes. What exactly are these whispers? They come from the churning dance of charged particles, accelerated by magnetic fields and the violent energy of young stars. Some signals trace the paths of molecules like carbon monoxide, mapping out vast, cold regions where new stars are just beginning to form. Others hint at shockwaves rippling through the nebula, leftovers from stellar explosions or the fierce winds of massive stars carving their surroundings. Perhaps most intriguing are the mysterious, flickering signals that defy easy explanation. Some astronomers speculate they could come from dense, dusty cocoons sheltering baby stars, or even from rogue objects like brown dwarfs, failed stars too dim to see. Every radio whisper adds another piece to the puzzle, helping us decode the nebula's hidden life. So while our eyes see a tapestry of light, the radio waves reveal the Orion Nebula's unseen heartbeat, a reminder that even in the quietest corners of space, there's always more to discover. Up next, we'll uncover another surprise, this time in the high-energy crackle of X-rays. But the Orion Nebula isn't just whispering in radio waves, it's also crackling with high-energy secrets. Hidden within its glowing clouds are bursts of X-rays, a discovery that caught astronomers off guard. Unlike the gentle hum of radio signals, these X-rays pack a punch, revealing the nebula's most violent and energetic processes. So where do these X-rays come from? Many erupt from young, fiery stars still in their cosmic infancy. These stellar toddlers are chaotic, unleashing violent flares hundreds of times more powerful than anything our sun produces. Their magnetic fields twist and snap, accelerating particles to near light speeds and sending X-rays screaming through space. But that's not all. Some X-rays might trace even stranger origins, collapsed objects like neutron stars or black holes lurking unseen in the nebula's depths. What's truly puzzling is how widespread these X-rays are. They don't just come from a few bright spots, they're scattered across the nebula, as if the entire region is buzzing with hidden energy. Some scientists think shockwaves from massive stars could be superheating gas, turning it into an X-ray factory. Others wonder if we're seeing the ghosts of long-dead stars, their remnants still radiating eons later. Every X-ray flash forces us to rethink what we know about stellar nurseries. The Orion Nebula isn't just a cradle for new stars, it's a high-energy battleground where birth and destruction collide. And just when we think we've seen it all, the nebula throws another curveball our way. Next up, we'll explore how its dust plays tricks on our eyes, casting shadows that dance across the cosmos. But the Orion Nebula's surprises don't stop at X-rays. Its dust is staging a cosmic magic show of its own. Picture this: thick clouds of dust drifting through the nebula, backlit by its brilliant stars. These dark ribbons don't just absorb light, they sculpt it, casting eerie shadows onto the glowing gas behind them. The result, a celestial shadow play that tricks our eyes into seeing depth, movement, and even phantom shapes where none truly exist. What makes this phenomenon so mesmerizing is how dynamic it appears. Some shadows stretch light years across, like giant fingers reaching through the nebula. Others flicker and shift over time, as if the dust itself is alive. Astronomers believe these illusions are created by dense, knotty filaments of dust passing in front of brighter gas clouds. But here's the twist: the shadows aren't just static silhouettes. Turbulent stellar winds and radiation pressure constantly reshape the dust, making the shadows writhe and twist over decades. The most famous example, the so-called Dark Bay, a vast shadow near the nebula's core that looks like a black tidal wave frozen mid-crash. Yet this isn't some solid structure. It's a trick of perspective, where dust closer to us blocks light from gas farther away. It's a reminder that in space, seeing isn't always believing. Even Hubble's sharpest images can't always untangle the nebula's three-dimensional puzzles at a glance. But these shadows aren't just cosmic eye candy, they're clues. By studying how light filters through the dust, scientists can map its density, temperature, and even its magnetic fields. Some shadows reveal hidden pockets of star formation, while others expose the violent aftermath of stellar winds carving through the nebula. It's like reading a story written in darkness, one where every shadow holds a secret. And just when you think the Orion Nebula has shown all its cards, it reminds us there's more to uncover. Next, we'll step back to see how this stellar wonder fits into a much larger cosmic neighborhood, one teeming with other enigmatic nebulae, each with its own mysteries waiting to be solved. Now, let's zoom out for a moment and see the Orion Nebula not as a lone wonder, but as part of a bustling cosmic neighborhood. Think of it like a vibrant city where the Orion Nebula is the dazzling downtown, and surrounding it are other enigmatic nebulae, each with its own unique character. Just as a metropolis thrives on the energy of its districts, this region of space hums with activity thanks to its celestial neighbors. Take M78, for example, a reflection nebula that acts like a cosmic mirror. Unlike the Orion Nebula's glowing gas, M78 doesn't produce its own light. Instead, it scatters the light of nearby stars, creating an ethereal blue haze. It's like the quiet artist's quarter of this stellar city, where dust and light collaborate to paint the sky. Then there's Demeron's Nebula, a smaller but equally fascinating patch of glowing gas nestled close to Orion's sword. It's often overshadowed by its flashy neighbor, but it holds secrets of its own, like how intense radiation from young stars can sculpt gas into delicate tendrils. But the connections run deeper than just proximity. These nebulae are all part of the same vast molecular cloud complex, a sprawling stellar nursery where stars are born and die in a cycle that shapes the entire region. The Orion Nebula might be the brightest jewel in this cosmic crown, but it's far from alone. Together, these nebulae form a dynamic ecosystem where stellar winds, radiation, and gravity constantly interact, rewriting the sky's landscape over millennia. What's truly remarkable is how these neighbors influence one another. Shockwaves from supernova in one nebula can trigger star formation in another, while fierce stellar winds carve out cavities that stretch across light years. It's a reminder that in space, no structure exists in isolation. Every glow, every shadow is part of a grander story. And as we'll soon see, even the Orion Nebula's most puzzling mysteries might find their answers by looking beyond its borders. Now, let's tackle one of the Orion Nebula's most puzzling mysteries, its missing mass. Astronomers have long noticed something strange when they crunch the numbers. The amount of gas they expect to find based on the nebula's brightness and structure doesn't quite add up to what they actually observe. It's like weighing a cake but discovering half the batter is unaccounted for. So where did this mass go? One theory suggests it's hiding in plain sight, locked away in dense, cold clouds of gas that are too faint for our telescopes to detect easily. These stealthy pockets could be scattered throughout the nebula, invisible to most wavelengths of light but still contributing to its total weight. Another possibility is that powerful stellar winds from young, energetic stars have blown vast amounts of gas out into deep space, redistributing the nebula's mass far beyond its visible boundaries. But here's where it gets even more intriguing. Some scientists speculate that the missing mass might be tied to rogue planets or brown dwarfs, objects too small to ignite as stars but too massive to be planets. These cosmic drifters, lurking unseen in the nebula's depths, could be tipping the scales without emitting much light. Or perhaps the answer lies in magnetic fields, which might be channeling gas into hidden streams or compressing it into structures we haven't yet mapped. Whatever the explanation, this missing mass mystery reminds us that even in a well-studied wonder like the Orion Nebula, there are still gaps in our understanding. It's a humbling glimpse into how much we have left to discover about the universe's grand puzzle. And as we'll see next, this isn't the only enigma waiting to be unraveled in Orion's glowing depths. Now, let's turn our attention to the wild and unpredictable weather of the Orion Nebula. Picture the most violent storm you've ever seen. Now imagine something 1,000 times more chaotic, with winds racing at millions of miles per hour. That's the kind of turbulence we're talking about here. The nebula's gas doesn't just sit still, it churns, swirls, and collides in a frenzy of motion. These aren't gentle breezes but colossal shockwaves, driven by the explosive energy of newborn stars and the violent deaths of others. It's like a cosmic hurricane where pockets of gas heat up to blistering temperatures while others cool into dense, dark knots. What makes this even more fascinating is how these turbulent motions shape the nebula itself. The supersonic winds carve out vast cavities, sculpting pillars of gas and dust into eerie formations. Some regions resemble the aftermath of a celestial explosion, with ripples and waves spreading outward like echoes in a storm. And just like Earth's weather, these movements aren't random. They follow the invisible forces of gravity and magnetism, twisting and folding the nebula's structure in ways we're still trying to understand. It's a reminder that even in the stillness of space, chaos reigns, and the Orion Nebula is one of the most dramatic examples of that. But the turbulence doesn't stop there. As we'll soon see, these violent motions are just one piece of a much larger puzzle, one that ties into the nebula's incredible ability to recycle itself over cosmic time. Now, let's take a closer look at one of the most awe-inspiring processes in the Orion Nebula: cosmic recycling. Imagine the life cycle of a star not as an ending but as a beginning. When massive stars reach the end of their lives, they don't just fade away quietly. Instead, they go out in spectacular fashion, exploding as supernova or shedding their outer layers in violent outbursts. These dramatic deaths are actually the universe's way of creating new life. As these stars explode, they blast heavy elements like carbon, oxygen, and iron into space, elements forged in their cores under extreme heat and pressure. These materials don't just vanish, they mix with the surrounding gas and dust, becoming the building blocks for future stars, planets, and even life itself. Think of it like a cosmic compost heap. The remnants of dead stars enrich the nebula, providing the raw ingredients for the next generation. Over millions of years, gravity pulls these enriched clouds together, forming new stars with planetary systems that might one day host rocky worlds or even life. What's truly mind-blowing is that the atoms in your body likely came from a star that died billions of years ago. The Orion Nebula is doing the same thing right now, scattering the seeds of future solar systems across space. It's a beautiful reminder that in the grand scheme of the cosmos, nothing is truly lost, only transformed. And speaking of transformations, this process ties directly into another mystery: how the nebula's turbulent motions spread these heavy elements far and wide, setting the stage for even more celestial wonders. Now, let's turn our attention to something a little more playful yet equally fascinating: the phantom shapes hidden within the Orion Nebula. Have you ever stared at the clouds and seen animals, faces, or even familiar objects? That same trick of the mind happens when we gaze at cosmic clouds, and the Orion Nebula is no exception. Across the centuries, astronomers and stargazers have spotted all sorts of eerie shapes in its swirling gas and dust. Some see a dragon coiled among the stars, while others swear they can make out a ghostly face peering back at them. There's even a shadowy figure that looks like a running man, though of course it's just dust playing tricks on our eyes. This phenomenon is called pareidolia, our brain's tendency to find familiar patterns in random shapes. It's the same reason we see faces in toast or figures in shadows. But in the Orion Nebula, the sheer scale of these illusions makes them even more mesmerizing. The dark lanes of dust, the glowing tendrils of gas, and the way light filters through them create an endless canvas for our imagination. What's truly intriguing is that these shapes aren't just random. The way dust and gas clump together, sculpted by stellar winds and gravity, forms structures that almost look intentional. Scientists study these formations to understand how turbulence and magnetic fields shape the nebula. But for the rest of us, they're a delightful reminder of how the cosmos sparks wonder in unexpected ways. So next time you see an image of the Orion Nebula, take a moment to look closer. You might just spot your own celestial phantom hiding in the depths of space. And speaking of hidden wonders, let's move on to another mystery: how light itself can play tricks on us across the vast distances of the cosmos. Now, let's uncover one of the most ghostly phenomena in the Orion Nebula: light echoes. Imagine a star suddenly flaring up, sending a burst of light racing through space. That light doesn't just vanish, it bounces off clouds of dust, creating delayed reflections that can linger for years, even decades. These eerie afterglows are called light echoes, and they act like cosmic time machines, showing us glimpses of stellar events long after they've happened. Here's how it works: when a star erupts, whether from a violent outburst or even a supernova, its light travels outward in all directions. Some of that light reaches us directly, but some hits dense patches of dust floating in the nebula. That dust scatters the light, sending it on a detour before it finally arrives at our telescopes. The result: a faint, shimmering halo that appears to expand slowly, like ripples in a pond. The strangest part: because the light takes a longer path, we see these echoes after the original event. It's like watching a replay of a cosmic explosion that happened years ago. Astronomers have used this phenomenon to study past stellar eruptions in incredible detail, almost as if they've been given a second chance to observe them. In the Orion Nebula, these light echoes are especially haunting. They drift through the gas clouds like phantom images, sometimes revealing structures we didn't even know were there. And just like the phantom shapes we talked about earlier, they remind us that the universe loves a good mystery, one where even light itself can bend time. But the Orion Nebula has more tricks up its sleeve. Next, we'll explore how its magnetic fields twist and turn, shaping the very fabric of this stellar nursery. Now, let's turn our attention to another hidden layer of the Orion Nebula's mysteries: polarized light. At first glance, light might seem straightforward, but when it passes through the nebula's chaotic clouds, it takes on a secret code. This phenomenon, called polarization, happens when light waves align in a specific direction, like soldiers marching in formation. And here's the fascinating part: this alignment isn't random. It's shaped by the nebula's invisible magnetic fields and the way dust grains are scattered across space. So, how does it work? Imagine sunlight reflecting off a lake. If the water's surface were perfectly smooth, the light would bounce off in a predictable way. But in the Orion Nebula, the water is a turbulent sea of gas and dust, and the sunlight comes from countless stars. As starlight travels through this cosmic maze, it interacts with dust grains which act like tiny mirrors. These grains aren't just floating randomly, they're subtly aligned by magnetic fields forcing the light to polarize. Astronomers use specialized tools to detect this polarized light, almost like putting on cosmic sunglasses. By studying its patterns, they can map the nebula's magnetic fields, revealing invisible forces that shape how stars form and gas moves. These fields are like cosmic puppet strings, guiding the collapse of gas clouds into new stars and even influencing the nebula's dramatic pillars and filaments. But polarization doesn't just expose magnetic secrets, it also tells us about the dust itself. The way light scatters reveals the size, shape, and composition of these tiny particles, helping scientists piece together the nebula's ingredients. Some grains are jagged, others smooth, and their alignment hints at the violent processes that forged them, from stellar winds to ancient supernova. What's truly mind-bending is that this polarized light isn't just a scientific tool, it's a glimpse into the nebula's hidden architecture. Without it, we'd miss the silent, magnetic choreography that underpins everything from star birth to the nebula's eerie glow. And just when you think the Orion Nebula has shown all its cards, it throws another curveball. Up next, we'll dive into the cosmic tsunamis that ripple through its gas, proving this stellar nursery is anything but calm. Now, let's plunge into the turbulent heart of the Orion Nebula, where cosmic tsunamis crash through its sea of gas with unimaginable force. These aren't waves of water, of course, they're colossal shock waves unleashed by the violent births and deaths of stars. Picture a stone dropped into a pond, sending ripples outward. Now, replace the stone with a supernova explosion or a newborn star's furious winds, and the pond with a nebula light years across. That's the scale we're talking about. These shockwaves are cosmic bulldozers, plowing through the nebula's gas at speeds of millions of miles per hour. When a massive star dies in a supernova, its final scream sends a supersonic blast wave surging outward, compressing and heating the surrounding gas. Meanwhile, young, hyperactive stars contribute their own chaos. Their stellar winds, streaming outward at breakneck speeds, collide with slower-moving gas, creating towering walls of shock-heated material. The effects are breathtaking. These tsunamis sculpt the nebula's landscape, carving out cavities and triggering chain reactions. When a shock wave slams into a dense gas cloud, it can squeeze that cloud just enough to spark the birth of new stars, like a cosmic domino effect. Other times, the waves shred delicate structures, leaving behind tattered filaments and glowing arcs. But here's the twist: these tsunamis aren't just destructive. They're also recyclers. As they tear through the nebula, they churn up heavy elements forged in stellar explosions, scattering them like cosmic fertilizer. This enriches the gas with ingredients for future stars and possibly even planets. Astronomers track these shockwaves by their telltale signatures: sudden spikes in temperature, bizarre gas motions, and eerie glowing fronts where the waves crash into cooler material. Some even produce eerie sound waves, though in space, no one can hear them rippling through the nebula's magnetic fields. And just when you think the Orion Nebula's drama couldn't get more intense, it reveals yet another layer. Up next, we'll explore the dense, star-forming globules lurking in its depths, stellar eggs waiting to hatch. Now, let's turn our attention to something equally fascinating but far more delicate: stellar eggs nestled within the Orion Nebula. These dense, shadowy globules of gas and dust are the cosmic cradles where new stars may one day awaken. Imagine them as tiny, dark cocoons, barely visible against the nebula's glowing backdrop, yet holding the potential to ignite entire solar systems. These globules, often called Bok globules after astronomer Bart Bok, are so dense that light struggles to pass through them. Inside, gravity slowly works its magic, pulling material inward until the pressure and heat become unbearable. Then a star is born. But here's the curious part: not all of these eggs hatch. Some linger in a state of suspended animation, resisting collapse for reasons that still puzzle scientists. One theory suggests that magnetic fields threading through these globules act like cosmic scaffolding, propping them up against gravity's relentless pull. Others speculate that turbulence within the gas, kicked up by nearby stellar explosions or fierce stellar winds, might keep the material too stirred up to settle into star formation. It's like trying to light a candle in a windstorm. The conditions just aren't right. Yet even the dormant ones tell a story. Their stubborn refusal to collapse offers clues about the delicate balance of forces at play in stellar nurseries. And when they do finally give in to gravity, the result can be spectacular. A single globule might birth not just one star, but an entire cluster, sending ripples through the nebula as new luminaries flicker to life. Astronomers study these stellar eggs with infrared telescopes, piercing their dusty shells to glimpse the faint warmth within. Some reveal faint protostars, infant stars still wrapped in their gaseous blankets, while others remain eerily quiet, their secrets locked away. And speaking of secrets, the Orion Nebula has one more cosmic surprise up its sleeve. Next, we'll uncover the hidden companions that might be lurking in its shadows, objects so elusive they've barely left a trace. Now, let's venture into the shadows of the Orion Nebula, where some of its most mysterious residents might be hiding in plain sight. Beyond the glowing gas and newborn stars, there could be unseen companions, rogue planets, brown dwarfs, or even black holes lurking undetected, their presence only hinted at by subtle cosmic clues. Rogue planets, for instance, are worlds untethered to any star, drifting through the nebula like cosmic nomads. These dark, frozen orbs might have been flung from their parent systems by gravitational chaos, or perhaps they formed alone in the cold embrace of interstellar space. Without a star to light them up, they're nearly invisible, detectable only if they pass in front of a distant light source or emit faint heat signatures. Then there are brown dwarfs, the so-called failed stars, too massive to be planets but too small to ignite full stellar fusion. These dim objects smolder in the nebula's outskirts. Some might be drifting solo, while others could orbit young stars, their faint glow drowned out by brighter neighbors. Astronomers hunt for them using infrared telescopes, searching for their telltale warmth against the cold backdrop of space. But the most elusive of all, black holes. While no confirmed black holes have been found in the Orion Nebula yet, the dense stellar environment makes it a prime hiding spot. A small, stellar mass black hole could be lurking there, its gravity subtly tugging on nearby gas or stars. If one exists, it might reveal itself by devouring a passing cloud of gas, sending out a fleeting X-ray signal before vanishing back into the dark. The challenge, of course, is proving any of these hidden objects exist. Their signatures are faint, their effects indirect, yet every unexplained wobble of a star, every odd distortion in the nebula's gas could be a whisper of their presence. And if we find them, they'd rewrite our understanding of how such objects form and wander through stellar nurseries. Up next, we'll tackle another puzzle: why the Orion Nebula's colors seem to shift depending on how you look at it, sparking debates among astronomers and stargazers alike. Now, let's turn our attention to a cosmic illusion that has puzzled both astronomers and casual stargazers: the ever-shifting colors of the Orion Nebula. Depending on how you observe it, this celestial wonder can appear dramatically different, sparking debates about what its true colors really are. Through the lens of a backyard telescope, the nebula often glows with a soft greenish hue, thanks to the dominant light emitted by ionized oxygen. But in long-exposure photographs, especially those taken by space telescopes, the scene transforms into a vibrant tapestry of reds, blues, and purples. The red comes from hydrogen gas, while the blue is scattered starlight reflecting off dust. So why the discrepancy? Part of the answer lies in human eyesight. Our eyes are far less sensitive to color in dim light than cameras are. In low light conditions, our vision relies more on rod cells, which detect brightness but not color. That's why when you peer through a telescope, the nebula's fainter colors blend into a muted green, the shade our eyes latch onto most easily. Cameras, on the other hand, can accumulate light over time, capturing the full spectrum our eyes miss. But there's more to it than biology. The filters and processing techniques used in astrophotography also play a role. Scientists often assign specific colors to different wavelengths of light to highlight chemical elements or structural details. For example, sulfur might be mapped to red, hydrogen to green, and oxygen to blue, creating those stunning, but not entirely natural palettes we see in processed images. This color controversy isn't just about aesthetics, it touches on a deeper question. How do we represent the universe when our tools and perceptions constantly reshape what we see? Whether you're gazing at the nebula through a telescope or marveling at a Hubble image, you're witnessing the same cosmic masterpiece, just through different lenses, both literal and metaphorical. Next, we'll explore how the Orion Nebula's violent stellar winds carve breathtaking sculptures into its gas clouds, shaping the nebula in ways that defy imagination. Now, let's zoom in on one of the most dynamic spectacles in the Orion Nebula: cosmic fountains of gas erupting into space like celestial geysers. These aren't gentle streams but violent jets, blasted outward at speeds reaching hundreds of thousands of miles per hour. The force behind them, newborn stars still in their fiery adolescence, unleashing unimaginable energy as they settle into their cosmic cradle. These fountains form when young stars, still swaddled in dense gas clouds, begin to spin and funnel material onto their surfaces. But not all that material sticks. Some gets channeled along magnetic field lines and shot out from the star's poles in opposing jets. Picture a garden hose with water bursting out at high pressure, except here, the water is superheated gas and the hose stretches light years across the nebula. What makes these jets so mesmerizing is how they sculpt their surroundings. As they plow through the nebula's gas, they carve out intricate tunnels and cavities, leaving behind glowing shockwaves where they collide with slower-moving material. Some even create bow shocks, arcs of luminous gas that resemble waves breaking against a cosmic shore. These structures are fleeting by astronomical standards, lasting only a few thousand years, but they're crucial for stirring up the nebula's chemistry, dispersing raw materials for future stars. Interestingly, not all jets are visible to the naked eye or even standard telescopes. Many reveal themselves only in infrared or radio wavelengths, where the cold, dense gas they're made of shines brightest. Others, though, light up in visible wavelengths, painting streaks of blue or red across the nebula's canvas. Their colors depend on the gas they're made of and how it interacts with the surrounding environment. Hydrogen glows red, while ionized sulfur can appear greenish-blue. These fountains aren't just beautiful, they're a vital part of stellar adolescence. By ejecting excess energy and material, young stars prevent themselves from spinning apart or overheating too soon. In a way, these outbursts are growing pains, cosmic tantrums that shape both the star and its nursery. Next, we'll witness how the nebula's appearance transforms over time, defying our expectations of how quickly the cosmos can change. But here's something even more mind-bending: the Orion Nebula isn't just a static painting in the sky. It's alive with motion, changing right before our eyes over mere decades. Unlike most cosmic phenomena that unfold over millions of years, parts of this nebula shift fast enough for astronomers to track in a human lifetime. Take the bright knots of gas near the Trapezium stars, for example. Time-lapse images reveal these regions expanding outward, some at speeds of over 100,000 miles per hour. What looks like a frozen snapshot in a single photograph becomes a cosmic ballet when viewed across years. Filaments of gas twist, pillars of dust collapse, and shockwaves ripple through the nebula like waves in a stormy sea. One of the most dramatic changes involves the famous proplyds, those planet-forming disks around young stars. Some have been seen evaporating or warping under the intense radiation from nearby massive stars. In just 20 years, a few have even vanished entirely, their material either blown away or swallowed by their central stars. It's a reminder that even in the vastness of space, destruction and creation often happen side by side. Then there's the nebula's overall brightness. While it might seem constant to the naked eye, sensitive instruments detect subtle flickers as pockets of gas heat up or cool down. Some areas grow dimmer as dense dust drifts into view, while others flare unexpectedly when hidden stars burst through their dusty cocoons. What's truly surprising is how these changes defy old assumptions. Astronomers once thought nebulae evolved too slowly to notice, but Orion proves otherwise. It's as if the universe pressed fast forward in this one corner of the sky, giving us a front row seat to cosmic evolution. Next, we'll uncover how the nebula's gravity bends light itself, acting like a lens to magnify secrets hidden far beyond it. Now, let's turn our attention to one of the most fascinating tricks the Orion Nebula has up its sleeve, its ability to bend light like a cosmic magnifying glass. This phenomenon, known as gravitational lensing, occurs when the nebula's immense mass warps the fabric of space-time around it. Just as a glass lens bends light to focus an image, the nebula's gravity distorts the path of light from objects lying far behind it, sometimes magnifying them or even creating multiple, stretched-out copies. Imagine holding a spoon over a newspaper. The curved surface twists and enlarges the text beneath it. The Orion Nebula does something similar on a galactic scale. When light from distant stars or galaxies passes through the nebula's dense regions, it gets bent, offering astronomers a rare peek at objects that would otherwise be too faint or distant to see. In some cases, this lensing effect even reveals galaxies billions of light-years away, hidden behind the nebula's glowing gas. What makes this especially intriguing is how it challenges our perception of the nebula's role. It's not just a stellar nursery or a cosmic light show. It's also a natural telescope, helping us uncover secrets of the universe that lie far beyond its borders. Scientists have used this effect to study everything from the formation of early galaxies to the distribution of dark matter within the nebula itself. But here's the twist: the lensing isn't perfect. Unlike a man-made lens, the nebula's uneven mass distribution creates distorted, often fragmented images. These quirks actually provide clues about the nebula's internal structure, like mapping the contours of an invisible landscape by how it bends the light. It's a reminder that even the universe's imperfections can become tools for discovery. Up next, we'll dive into another unexpected feature: how the nebula's supersonic gas motions could, in theory, create sonic booms louder than anything on Earth. Now, let's shift our focus to something that defies the silence of space: the Orion Nebula's hidden symphony of sonic booms. While space is famously a vacuum where sound can't travel, the nebula's chaotic gas movements create shockwaves that would be deafening if we could hear them. Picture a jet breaking the sound barrier on Earth, unleashing a thunderous boom. Inside the Orion Nebula, gas surges at speeds exceeding 1 million miles per hour, colliding and compressing with such force that it generates similar shockwaves, only these are cosmic in scale. What's fascinating is how these supersonic motions sculpt the nebula itself. As young stars unleash torrents of radiation and stellar winds, they push surrounding gas at blistering speeds. When this gas slams into denser regions, it doesn't just ripple, it explodes into violent fronts of energy, heating the gas to extreme temperatures and carving intricate structures. Astronomers call these collisions bow shocks, and they're visible as glowing arcs in the nebula's tapestry. Here's the twist: if sound could travel in space, these shocks would register as continuous, earth-shaking roars, far louder than anything possible on our planet. But since space lacks air to carry sound waves, the energy dissipates as heat and light instead. Yet, by studying these silent shockwaves, scientists can map the nebula's invisible turbulence like tracking a storm by its lightning. This phenomenon also reveals a hidden violence in stellar nurseries. The same forces that birth stars also tear through their surroundings, proving that creation in the cosmos is anything but gentle. Up next, we'll unravel the nebula's filamentary cosmic web, a delicate network of gas threads connecting its chaos like celestial spider silk. Now, imagine stepping back to see the Orion Nebula not just as a glowing cloud, but as an intricate cosmic spiderweb. This sprawling network of filamentary structures weaves through the nebula like delicate threads, connecting its brightest regions to its darkest corners. These filaments are not random, they're highways of gas and dust, shaped by gravity and magnetic fields, guiding the flow of material across the nebula. What makes this cosmic web so fascinating is how it mirrors the structure of a spider's silk. Some filaments are thin and wispy, barely visible against the nebula's glow, while others are thick and dense, acting as cosmic pipelines funneling gas toward star-forming hubs. Scientists believe these threads are the scaffolding of star birth, channeling raw material into pockets where gravity can collapse it into new suns. Here's where it gets even more intriguing. These filaments aren't static, they pulse and shift over time, responding to the violent energy of nearby stars. Radiation and stellar winds stretch and twist them, sometimes even tearing them apart, only for new threads to form elsewhere. It's a dynamic, ever-changing tapestry, revealing how the nebula constantly rebuilds itself. By studying this web, astronomers gain clues about how star-forming regions evolve. The filaments act like cosmic blueprints, showing where the next generation of stars might ignite. And just like a spider's web catches prey, these structures trap and concentrate the ingredients for stellar birth, proving that even in the vastness of space, the smallest threads can shape the grandest designs. Next, we'll zoom in on one of the nebula's most elusive features, phantom jets that flicker in and out of existence, defying our expectations of cosmic behavior. But just when you think you've seen all the Orion Nebula's tricks, it throws another mystery your way. Picture this: narrow, high-speed jets of gas shooting through the nebula like cosmic fireworks, only to vanish without a trace moments later. These phantom jets are some of the most baffling features in Orion, appearing and disappearing so unpredictably that astronomers often debate whether they were ever there at all. What makes these jets so elusive? Unlike the steady streams of material we see from many young stars, these flickering tendrils seem to operate on their own chaotic schedule. Some last for mere months before dissolving back into the nebula's glow, while others reappear years later in slightly different positions. It's as if the nebula itself is playing a cosmic game of hide and seek. The leading theory suggests these jets come from newborn stars buried deep within dense gas clouds. As these stars spin and accrete material, they occasionally spit out narrow beams of gas at supersonic speeds. But when the surrounding dust shifts or the star's activity wanes, the jets can be abruptly cut off or obscured from our view entirely. Here's where it gets even stranger. Some phantom jets leave behind ghostly afterimages, heated patches of gas that linger long after the jet itself has faded. These remnants act like cosmic breadcrumbs, hinting at violent outbursts we might have missed. And in rare cases, multiple jets crisscross the same region, creating a tangled web of temporary structures that defy simple explanations. Studying these fleeting features is like trying to catch smoke with your hands. But every glimpse teaches us something new about the turbulent youth of stars, and reminds us that even in a nebula we've observed for centuries, surprises lurk around every corner. Now let's turn to an even more dramatic cosmic spectacle: stellar cannibalism, where stars steal material from their neighbors in a ruthless fight for survival. But the Orion Nebula isn't just a place of fleeting jets. It's also a cosmic battlefield where stars wage silent wars over survival. imagine a crowded stellar nursery where young stars are packed so tightly that they begin stealing material straight from their neighbors. This ruthless act, known as stellar cannibalism, is one of the most dramatic struggles playing out in Orion's heart. When stars form in dense clusters, their gravitational pull can turn vicious. Larger, more massive stars often bully their smaller siblings, siphoning off gas and dust that would have fueled their growth. It's a celestial heist where the strong thrive and the weak are left starved, literally. Some stars don't just steal material, they merge entirely, colliding in violent encounters that reshape their futures. What's truly fascinating is how this chaos leaves behind clues. Astronomers have spotted stars with unusual chemical compositions, hinting at stolen material from their neighbors. Others show erratic orbits, as if they've barely escaped a gravitational tug of war. And in the most extreme cases, stars are caught in the act, their outer layers stretched into long, glowing streams of stolen gas. This isn't just cosmic drama, it's a key piece of the puzzle in understanding how star clusters evolve. The Orion Nebula's crowded environment turns stellar cannibalism into a common survival tactic, proving that even in the beauty of space, nature follows one ruthless rule: adapt or fade away. Now let's shift our gaze to something even more explosive: radioactive elements scattered through the nebula, whispering secrets of ancient stellar explosions. But the drama of stellar cannibalism isn't the only violent history written across the Orion Nebula. Hidden within its glowing clouds lies another explosive signature: radioactive elements that act like cosmic clocks, ticking away the moments since massive stars met their fiery end. Among these radioactive fingerprints, aluminum-26 stands out. This unstable isotope forms in the furious hearts of giant stars and gets blasted into space when those stars explode as supernova. What makes it special is its half-life, around 700,000 years. That's just long enough for astronomers to detect its faint gamma-ray glow before it decays completely. When they spotted aluminum-26 in Orion, it was like finding a still warm gun at a crime scene, evidence that a supernova detonated here relatively recently, at least by cosmic standards. But the plot thickens. Some researchers argue the aluminum-26 might not come from a single cataclysmic blast, but from multiple generations of massive stars dying in waves. Others suggest it could be streaming in from nearby star-forming regions carried by stellar winds. Either way, its presence reshapes our understanding of Orion's timeline. If supernova have been erupting here within the last million years, they've likely triggered new rounds of star birth by compressing nearby gas clouds, meaning the nebula's dazzling stellar nursery might owe its existence to ancient explosions. This radioactive glow does more than mark past violence, it seeds future worlds too. Aluminum-26 decays into magnesium-26, an element that gets baked into forming planets. Some scientists even think the heat from this decay could have helped melt early asteroids in our own solar system. So next time you look at Orion's shimmering clouds, remember, you're not just seeing light. You're witnessing the aftermath of stellar bombs still echoing through space. Now, let's turn to an even more dazzling spectacle: cosmic fireworks lighting up the nebula in bursts of color and energy. Now, imagine the Orion Nebula lighting up the cosmos like the grand finale of a fireworks show. These aren't your typical 4th of July sparklers. These are stellar explosions painting the void with bursts of color and energy. When massive stars reach the end of their lives, they don't fade quietly. Instead, they go out with a bang, ejecting glowing gas and dust in dazzling displays that rival any earthly pyrotechnics. The vibrant hues come from superheated elements flung into space. Oxygen burns blue-green, sulfur radiates red, and hydrogen glows pink, creating a celestial palette that telescopes capture in breathtaking detail. But what really makes these cosmic fireworks spectacular are the shock waves. As the explosion's energy slams into surrounding gas, it creates rippling fronts of compressed material, like the sonic booms of a fireworks burst, but on a scale spanning light years. These shockwaves do more than dazzle. They sculpt the nebula, carving out cavities and triggering new star formation by squeezing nearby gas clouds. Some astronomers even compare the process to a chain reaction, one stellar explosion setting off another, like fireworks igniting in sequence across the sky. And just like fireworks, these events are fleeting. The brilliant ejecta fade over centuries, leaving behind only traces of their explosive past. Yet every time we observe the Orion Nebula, we're catching these fireworks in action. Some are fresh, their shockwaves still expanding. Others are remnants, their glow dimming but their influence still shaping the nebula's future. It's a reminder that the cosmos isn't just a static painting. It's a dynamic, ever-changing spectacle, with the Orion Nebula as one of its most vibrant stages. Speaking of stages, let's turn our attention to another hidden force at work, the twisted magnetic fields weaving through the nebula like invisible threads. Now picture the Orion Nebula as a cosmic loom, weaving invisible threads of magnetic force through its glowing clouds. These aren't just random lines, they're intricate braids of magnetic energy, twisting and turning like tangled ribbons in a stellar wind. Scientists believe these magnetic fields play a crucial role in shaping the nebula's structure, acting like invisible highways that guide gas and dust toward newborn stars. The braids form as chaotic motions in the ionized gas stretch and twist the magnetic field lines, creating loops and kinks that resemble a tangled spiderweb. In some areas, these braids tighten, squeezing gas into dense knots where gravity can take over, collapsing the material into protostars. It's as if the nebula itself is funneling fuel directly into stellar nurseries, using magnetism as its delivery system. What's truly fascinating is how these magnetic fields defy expectations. Unlike the orderly patterns we see around planets like Earth, the Orion Nebula's braids are wild and unpredictable, shaped by the violent energy of young stars and supersonic gas flows. Some researchers compare them to cosmic lightning, jagged, dynamic, and crackling with energy. Yet despite their chaos, they seem to impose a strange order on the nebula's turmoil, directing the flow of matter with unseen precision. And just like a rope made of intertwined fibers, these magnetic braids may be stronger than they appear. Simulations suggest they could withstand the nebula's turbulent forces, persisting long enough to shepherd gas across vast distances. Without them, star formation might be far less efficient, like trying to build a sandcastle in a hurricane without your hands. As we peer deeper into the nebula's magnetic tapestry, one question lingers: could these braids hold the key to unlocking how stars are born? The answer might be woven into the very fabric of Orion itself. Up next, we'll confront an even deeper mystery: the ghostly hints of dark matter hiding within the nebula's swirling gases. But before we dive into the shadows, let's shine a light on one of the Orion Nebula's most puzzling riddles: the whispers of dark matter lurking within its swirling gases. While we can't see this elusive substance directly, its presence might be betrayed by the strange behavior of the nebula's visible material. Take the way gas clouds move in certain regions. Some drift at speeds that defy gravity's usual grip, as if tugged by invisible hands. Others swirl in patterns that don't quite match the pull of the stars we can see. These odd motions hint at something massive yet unseen, perhaps dark matter, the mysterious substance that makes up most of the universe's mass but refuses to interact with light. Here's where it gets intriguing. If dark matter is woven into the nebula, it could be warping the very fabric of its star-forming regions. Picture a hidden scaffold beneath a construction site, silently shaping where towers rise. Similarly, dark matter's gravitational influence might steer gas into denser clumps, accelerating star birth in ways we don't yet understand. Yet the Orion Nebula doesn't make it easy. Unlike galaxies where dark matter's signature is clearer, this stellar nursery is a riot of competing forces: stellar winds, radiation, and magnetism, all muddying the clues. Some scientists argue the anomalies could just be turbulence from newborn stars. Others wonder if we're glimpsing dark matter's finer threads, tangled where we least expect them. One thing's certain: if dark matter is here, it's playing a subtle game. Unlike the nebula's glowing braids and fiery jets, this phantom leaves no flashy traces, just gravitational breadcrumbs. And that makes it the ultimate cosmic hide-and-seek champion. Up next, we'll listen closely as the nebula's gases hum with sound like waves, turning this cosmic cloud into an echoing chamber of secrets. Now, let's tune our ears to the Orion Nebula's hidden symphony, where sound doesn't travel the way you'd expect. In the vacuum of space, there's no air to carry noise, but inside this dense cosmic cloud, gases behave differently. Packed so tightly, they create a medium where pressure waves can ripple, much like sound through Earth's atmosphere. These aren't ordinary sound waves, though. They're colossal vibrations, some spanning light years, generated by violent stellar births or the explosive deaths of massive stars. Picture dropping a boulder into a pond, but here the ripples are supersonic shock waves, racing through the nebula's labyrinth of gas at hundreds of thousands of miles per hour. What's eerie is how these waves linger. The nebula's dense structure acts like an echo chamber, bouncing and distorting the waves until they create a ghostly resonance. Astronomers detect these echoes indirectly, observing how they compress gas into glowing filaments or trigger pockets of star formation. It's as if the nebula is whispering its secrets through these vibrations, leaving behind a trail of cosmic breadcrumbs. But here's the twist: these waves might also solve a mystery. Some scientists suggest they could explain why certain regions of the nebula stay turbulent long after the initial stellar fireworks have faded. Like a bell struck once but ringing for centuries, these sound-like waves may keep the nebula's gases churning, shaping its evolution in ways we're just beginning to decode. Up next, we'll delve into an even stranger idea. Could the nebula's gases exhibit behaviors that blur the line between chemistry and something almost lifelike? Now, let's venture into one of the most mind-bending ideas about the Orion Nebula. What if its gases aren't just chaotic clouds, but something eerily lifelike? Scientists have long observed that the nebula's plasma, superheated gas where atoms split into charged particles, doesn't always behave randomly. Instead, it sometimes forms intricate, self-organizing structures that seem to mimic the patterns of simple life. Picture this: vast, swirling tendrils of ionized gas that twist and fold like living tendrils, or glowing filaments that branch out like cosmic veins. These shapes aren't just accidents, they emerge from the plasma's natural ability to respond to magnetic fields and energy flows, creating order out of chaos. Some researchers even compare these structures to slime molds or bacterial colonies, which organize themselves without a central brain or blueprint, the wildest part. Under the right conditions, these plasma formations can replicate behaviors we typically associate with life, such as movement, growth, and even rudimentary problem-solving. For example, when currents flow through the nebula's plasma, it can reconfigure itself to follow the path of least resistance, almost like a living organism adapting to its environment. Of course, this isn't actual life, no DNA, no cells, but it blurs the line between chemistry and biology, hinting at how lifelike complexity might arise from simple physical laws. Some theorists speculate that if plasma can self-organize so dramatically in space, it could reshape our understanding of where and how life might emerge in the universe. Up next, we'll peer into the future and ask, what fate awaits the Orion Nebula and how will its story end? Now, let's fast forward through cosmic time and ask a haunting question: what happens when the Orion Nebula's story finally ends? This stellar nursery, vibrant with young stars and glowing gas, won't last forever. In fact, astronomers predict its fate hinges on a celestial tug of war between creation and destruction. Right now, the nebula's massive stars are both its architects and its wrecking crew. Their fierce radiation sculpts the gas into breathtaking shapes, but those same stars are also blowing the nebula apart. Stellar winds and supernova explosions, some of which may have already happened, their light still traveling toward us, will gradually shred the nebula's delicate structures. Over the next 100,000 years, the gas will disperse like smoke dissolving into a breeze. But here's the twist, not all of it will vanish. Dense pockets of gas, shielded from the chaos, might collapse into new stars, repeating the cycle. Meanwhile, the Trapezium cluster's stars will drift apart, their gravitational bond weakening as they age. Eventually, Orion's iconic glow will fade from our night sky, leaving behind only scattered stars and ghostly traces of ionized gas. For Earth-bound stargazers, the change will be bittersweet. In a few million years, Orion's sword may appear dimmer, its fuzzy star gone. But the nebula's legacy will endure, its expelled elements will seed future stars and planets, perhaps even life. And who knows, some of its surviving infant stars might one day host worlds where beings gaze up, wondering about the cosmic clouds that birthed them. Next, we confront the Orion Nebula's greatest unsolved riddle, a mystery that defies even our boldest theories. But before we close this cosmic journey, let's linger on the Orion Nebula's most baffling secret, the one that keeps astronomers awake at night. Despite everything we've uncovered, this stellar nursery still guards puzzles that defy explanation. For starters, where are all the missing stars? The nebula's heart should be teeming with young suns, yet observations reveal far fewer than predicted. Some may be hidden behind thick dust, but others seem to have vanished entirely. Could they have been ejected by violent interactions, or worse, swallowed by something unseen? Then there's the enigma of the nebula's unexplained energy surges. Occasionally, pockets of gas flare with intensities that shouldn't be possible from known stellar processes. Some theorists whisper about rogue black holes or exotic particles, while others suspect we're witnessing entirely new physics. Even the nebula's magnetic fields behave oddly, twisting in ways that challenge our models of cosmic magnetism. And let's not forget the whispers of dark matter, subtle gravitational tugs that hint at invisible mass woven through the gas clouds. Could this be the key to the nebula's strangest motions, or just another dead end? The truth is, for every mystery solved here, two more take its place. That's the beauty of the Orion Nebula. It doesn't just show us how the universe works, it taunts us with what we don't yet understand. And perhaps that's its greatest gift, a reminder that the cosmos always has another card up its sleeve. Now, as we wrap up our exploration of these 50 wonders, let's take one last look at the bigger picture. From swirling stellar nurseries to ghostly silhouettes, the Orion Nebula has revealed itself as a cosmic masterpiece where science and mystery collide. We've wandered through its glowing heart, traced the arcs of its hidden magnetic fields, and even glimpsed the phantom shapes that stir our imagination. Each of these 50 phenomena, from the Trapezium cluster's stellar ballet to the eerie whispers of dark matter, paints a portrait of a nebula that's as enigmatic as it is breathtaking. What makes this celestial wonder truly special isn't just what we've uncovered, but what remains just out of reach. The missing stars, the unexplained energies, the way it seems to toy with our understanding of the universe. These aren't flaws in the cosmos. They're invitations to look deeper, to question boldly, and to remember that the night sky is still the greatest mystery novel ever written. So the next time you find yourself under a clear, dark sky, trace Orion's belt with your finger and let your gaze drift to that faint smudge in his sword. Know that you're looking at a stellar nursery where stars are born, where gas dances in shapes both beautiful and bizarre, and where the universe whispers its secrets to those willing to listen. If this journey through the Orion Nebula's wonders has left you as awestruck as we are, don't let the curiosity end here. Hit that subscribe button and ring the notification bell, because the cosmos has endless mysteries waiting to be explored, and we're just getting started. Until next time, keep looking up. The universe has so much more to show you.